Hello everyone, welcome to Math World. This video is to discuss Cambridge International ASN A-Level Mathematics Paper 4, which is the mechanics for May-June 2024, and the code is 9709/41. So let's get started. Okay, question number 1. A car starts from rest and accelerates at 2 meters per second squared for 10 seconds. It then travels at a constant speed for 30 seconds. The car then uniformly decelerates to rest over a period of 20 seconds. Okay, now first part is sketch a velocity time graph for the motion of the car. Now first of all, we know that it starts from rest, means that the velocity, this is a v, velocity versus time, t. So at first, since it starts from rest, that means when t equals to 0, v equals to 0. That's the meaning of rest. Now accelerates at 2 meters per second squared for 10 seconds. So we know that acceleration equals to velocity over time. So now the acceleration is given, this is a, and the time is 10. Alright, that means here I can find my v, which means my v is basically a times t. That is, a is 2, t is 10. That means within 10 seconds, the velocity will speed up to 20 meters per second. Alright, so now from here, I know that when t equals to 10, okay, your v equals to 20. So at first, 0. Alright, so let's say this is 10, here is 20. So then for 10 seconds, so let's say this is 10 seconds. So from 10 seconds, I mean from 0 to 10 seconds, the v becomes 0 to 20. Okay, as shown in the calculation. So I join these 2 points by a straight line. Okay, so please join these 2 points using a ruler. It should be a straight line. Okay, now then it then travels at a constant speed for 30 seconds, means that for another 30 seconds, it will be v equals to 20, constant speed. So 30 seconds added to the 10 seconds, it will be up to 40 seconds. So here 20, this is 30, here is 40. Use the same scale. Okay, so constant speed, 20 meter per second squared, meter per second. So this is 30 seconds. Then the car uniformly decelerates to rest over a period of 20 seconds. Another 20 seconds, it comes to rest. So come to rest means that it becomes 0. So this is 50, here is 60. So drop to 0. Okay. Alright. So my axis is not very accurate, so probably I just adjust a little bit here. 20, 30, 40, 50, and 60. Alright, so 30 seconds from 10 means that it stops at 40. Then from 40, another 20 seconds, the velocity becomes 0. So this is your graph. So it must be a straight line. This is a straight line. Okay, so done for the A. Now B, find the total distance traveled by the car. So since now you have the V against T, we know that V is actually S over T. Okay, that means S equals to VT. So which means that is the multiplication of the V and T axis. V and T axis. So which means that is the area under the curve. Right, so here I will write total distance equals to area under the curve. And now when you look at the curve, it is basically a trapezium. Okay, throughout the 60 seconds. So it's a trapezium. So according to trapezium, let's say like this, you are given two parallel sides, A and B, and then the height is C. So the area is going to be half of A plus B times C. So now our C here, okay, is 20. And then our A here is going to be 40 minus 10. That is 30 seconds. Then the another parallel side here is going to be 60. Okay, and then now substitute into this formula. So it will be half of 30 plus 60, then multiply with 20. So here I will just write this is half of 30 plus 60, then multiply with 20. Okay, that means now at last you will be getting 900 meters. That will be the total distance traveled by the car. Question number 2. Two forces of magnitudes 20 newtons and F newtons act at a point P in the directions shown in the diagram. So this is a point P. Now, A, given that the resultant force has no component in the y direction, that means now your resultant force only has x direction. So, calculate the value of F. Okay, so from here, so if no y direction means that I will say that now basically my F Newton will be balanced with the 20 Newton after you resolve it vertically. Alright, so when you resolve vertically, now since the alternate angle is 60 degrees, I'm going to use this 60 degrees. That means I will just write my F is balanced with the 20 newtons or 20. Since I'm using the alternate angle, therefore it is sine. So it will be 20 sine 60 degrees. Okay, because there's no resultant force. So which means when you consider the upwards and downwards force, it will be equal. So your resultant force will be 0 because the upward force is same as the downward force. So it will be balanced off. So then here is going to be 20 sine 60 degrees is square root 3 over 2. Therefore, I will be getting 10 square root 3. That is my F. Now B, given instead F equals to 10. Now find the magnitude and direction of the resultant force. Okay, now your F is 10. This is 10 newtons. Okay, so here I will calculate. Let the upper force be positive, be Fy. Okay, Fy will be the upwards force. So if upward force is the Fy, that means I will use this 20, resolve vertically, you resolve 20 newtons vertically and minus the 10 newtons because I consider my Fy pointing upwards. So it will be Fy equals to 20 sine 60 degrees minus 10. Okay, so now here, sine 60 is basically square root 3 over 2. Now, you can just copy from here. 20 sine 60 is actually 10 square root 3. So here I will just direct write 10 square root 3. Then minus 10. This is my upward force. Okay, now, my horizontal force, I consider pointing to the right as positive. So, and I label this force as Fx. So now, when you refer to the diagram, I only have one horizontal force, which is you resolve this 20 to the x-axis. Okay, so when I resolve this 20 to the x-axis is using 60 degrees. Okay, by using the 60 degrees, that means the force, the resolved force becomes 20 cos 60. So you must remember whenever you use the given angle, that is cos. Right, so I will write 20 cos 60 degrees. And this is going to be 20 cos 60 is half. Therefore, you are getting 10. Okay, so for your information, this 10 square root 3 minus 10 is actually a positive value. That means now my resultant force, I will be pointing up, okay, going up, Fy, and then my fx is to the right side. Okay, so it's like this, to the right side. So, but then I can say it will be fx toward the right side, then followed by going up. So therefore my resultant force is actually here. Alright, so now my Fr, according to this, right, because the horizontal force is perpendicular to the upward force, so I can just use the Pythagoras theorem. So it will be square root of fx squared plus fy squared. That will be my Fr. So which means I will be getting square root of fx is 10, so 10 squared plus fy squared, it will be 10 square root 3 minus 10. Then I squared it. And now here, when you calculate the value, it will be 12.3931. And now I round up to 3 significant figures. Look at the 9, so round up, the 3 becomes 4. So my resultant force is 12.4 newtons. So you need to find out the magnitude and direction. So now basically the direction is here. This is the theta. Okay, so I will say that my theta equals to, now for your information, tangent theta is Fy over Fx, opposite over adjacent. That means now my theta is going to be, okay, so I will just do it here. Probably I do it here. So tangent theta is Fy over Fx, which means my theta is basically inverse tangent. Now Fy, okay, Fy is 10 root 3 minus 10 over Fx is 10. Okay, then from here you will get 36.2 degrees. Now for the directions of the resultant force, okay, so now you can just write the direction. Okay, so you define first. Let Fr be the resultant force. So the direction of resultant force is 36.2 degrees towards, from the positive fx, okay, or from the positive horizontal line, for horizontal line. Okay, so done for this resultant force and its magnitude. Okay, now next question. Number 3. A train of mass 180,000 kilograms ascends a straight hill of length 1.5 kilometers, inclined at an angle of 1.5 degrees to the horizontal. Okay, so probably here I can just write 36.2 degrees to the horizontal. Okay, now as it ascends the hill, the total work done to overcome the resistance to motion is 12,000 kilojoule. Right, so this is the total work done to against the resistance, and the speed of the train decreases from 45 meter per second to 40 meter per second. That means this is the initial speed, this is the final speed. Now find the work done by the engine of the train. So work done by engine of the train as it ascends the hill, giving your answer in kilojoule. Okay, so now here I will write this first, 12,000. So that is the work done against resistance, equals to 12,000 kilojoule. So but then we know that kilojoule, kilo means 10 times power 3. Alright, that means this is basically 12,000 times 10 power 3 joule. So you must calculate in joule. Now, the total work done, okay, or I will refer to the work energy principle. So from work energy principle, total work done, or I will say that it is net work done, right? So you can just write total work done. That is defined as increase in mechanical energy. Okay. So now, the total work done is defined as work done by engine to speed up the train. Okay, so work done, I will write work done by engine minus work done against, so I will write here, minus work done against the resistance. So that's why I call that's why I said that is the net work done. Right, against resistance equals to increase in mechanical energy, that is increase in kinetic energy. Okay, kinetic energy plus increase in gravitational potential energy. This is our GPE. Okay, and the kinetic energy is actually KE. Alright, so to solve this, what to do is, now work done by engine, we are not sure. Okay, that is what we need to calculate. So probably I just let it be WD, right? WD. So that means now WD minus work done against resistance is given, which is this value. So 12,000 times 10 power 3. So here 12,000 times 10 power 3. Okay, increase in kinetic energy. Now, probably I have to draw a diagram. Let's say this is the diagram. Okay, you are given the train of mass 180 kilograms, 180,000 kilograms. So it mentioned that it ascends. Its ascends means that going up. So means that your train will be here. Okay, it goes up to here. This is 180,000 G. Okay, 180,000 kilograms. Now this is the weight. Here, angle is 1.5 degrees. It's given in the question, 1.5 degrees. Now, the length of the hill is 1.5 kilometers. So, which means here is 1.5 kilometers. Okay, then the U is 40, U is 45, V is 40. So, it means that U is 45, V is 40. The train is going up. Okay, so now, when you need to find the increase in kinetic energy. So increase in kinetic energy, this is basically the final KE. Okay, I write here. This is basically final kinetic energy minus initial kinetic energy. And then the increase in GPE, this is basically final GPE minus initial GPE. Okay, so now the kinetic energy formula, alright, this is half mv squared. And then for the GPE, gravitational potential energy formula, that is mgh. Alright, so from here, my increase in kinetic energy is basically half m, that is half, my m is 180,000. Okay, that is my m. And then my final kinetic energy means that is the final speed. Okay, so because I have taken out the half m, then here initial kinetic energy, it will be half mu squared. So I will just write this is going to be v squared minus u squared. So 40 squared minus 45 squared. Because I factorize a half m is in common. Now I plus with, okay, plus with mgh. Again, the mgh, this mg are in common. Okay, so the mg is basically 180,000 g. So the g is replaced by 10. Therefore, I will write 1. Okay, I do not have enough space. I write next line. So here, plus 180,000. This is my m. My g is going to be 10. Okay, g. My h, I need to find out what is my distance here. What is my h? This is my h. Okay, so when you look at here, I know that this length is 1.5 kilometer. That means I write here, this is 1.5 kilometer. I need to find out what is my h. Here is 1.5 degrees. That means this is also 1.5 degrees. Okay, so when you need to find out the h, now basically when you refer to the diagram, this 1.5. Now, the h is the opposite side to the 1.5 degrees, and then this 1.5 kilometers, that is the hypotenuse, right? So now I will draw this out. This is h. Now 1.5 kilometers means that it is 1.5 times 10 power 3 meters, because we need to calculate our distance in meters, right? Because your u is in meter per second, so you must use back the same unit, which is in meters instead of kilometers. So now here, okay, I write properly. This is h. Here is 1.5 times 10 power 3 meters, and this angle is 1.5. Now, if you refer to the right angle triangle, h is the opposite side, and 1.5 times 10 power 3 is the hypotenuse. So you have opposite and hypotenuse, that is sine. So I will write sine 1.5 degrees, that is h over 1.5 times 10 power 3, which means my h is going to be multiplication. Okay, so therefore my last h, okay, my final h here, that is going to be 1.5 times 10 power 3 sine 1.5 degrees. Then I minus the initial position, okay, the initial h. I treat this as the 0 because my h is counted from the initial position. So means that h equals to 0. Alright, so from here, to find the work done, just move the negative 120,000 times 10 power 3 to the right side and calculate all the rest of the values. So now my work done equals to, now when you calculate this value, that is negative 3825, then 0000, then plus, and now when you calculate all this, right, that is going to be 70,677,760.43, and this negative 120,000 times 10 power 3 will be moved to right side. That means it becomes a plus. So here plus 120,000 Okay, 100, and this is, sorry, let me check. This is 12,000. Okay, not 120,000. 12,000 times 10 power 3. Okay, so now when you calculate all these values, that is going to be 444,277,60.43 joule. Okay, that is the work done. But then when you look at the question says kilojoule. So when kilojoule, we know that 1 kilojoule is 1000 joule. So now what you need to do is you just divide by 1000, or just move this decimal 3 places backwards. Okay, that means I will be getting equals to 444,27.76043 kilojoule. And now we need to leave our answer correct to 3 significant figures. So 3 significant figures will be these 3 values, but then it depends on the next value. So since the next value is 2, therefore just change to 00. Okay, so I will be getting 44, 3 significant figures. So 444, then 00 kilojoule. So that is the work done by the engine. Okay, now for question number 4. A car of mass 1,700 kilograms is pulling a trailer of mass 300 kilograms. So this is a car, and then this is a trailer along a straight horizontal route. The car and trailer are connected by a light inextensible cable which is parallel to the route. There are constant resistances to motion of 400 newtons on car and 150 newtons on the trailer. So all these two are the resistance forces. Now the power of the car's engine is 14,000 watt. Find the acceleration of the car and the tension in the cable when the speed is 20 meters per second. Okay, basically this is the diagram. This is a route. Okay, say this is a car, right? And this is a trailer. Okay, so now there will be a cable here. So cable has tension, 2 directions. And then the car, okay, for the car, there will be a resistance force of 400. So this is FC. I use C to represent car. Let C be car. Okay, then let T be trailer. So for trailer, there will be a force as well, resistance force. So this is 400, and this FT is 150. Okay, now the car is moving to the right side. Okay, and since there's a power, that means here you will have driving force, right, for the car. So now M car or MC, our MC, C means car, means MC is the mass of the car, 1,700 kilograms. The MT, mass of the trailer, that is 300 kilograms. Okay, now given the power, okay, so we know that power, I will have to define first. Let D be the driving force of the car. Okay, so the power is actually defined as D times V, whereby the V is the speed. Okay, V is a speed. Now from here, the speed is given 20, alright, and then the power is given. So that means 14,000 equals to D times 20, speed of the car. Right? Now your D is going to be 14,000 divided by 20. Then that is 700 newtons. So now your D is 700. Now to find the acceleration and the tension, okay, I will refer to the Newton's second law. So F equals to ma. Now, you have two options. The first is you just consider whole system. Alright, so here I will consider whole system. Then I can find the A directly, because now they are moving to the right side. So this is the A direction. Okay, so now when you consider the whole system, actually these two t will not be considered because both are cancelled off. Alright, one goes to left and one pointing to a right side. So I will just consider the rest of the forces except the two t's. So now, since the whole motion is towards right side, so towards right side is considered as positive. That means the forces towards right side will be positive as well. So which means now here I get D, okay, D minus Fc, then minus Ft, because Ft and Fc are in the opposite direction of the D. Then equals to the M. M here is the total mass. And then A. And now we need to find out what is the A. So just replace all the values. D is replaced by 700. Then Fc is 400. Ft is 150. Then MC given 1700 plus MT 300. Then multiply with A. Okay, then from here, left hand side is 150, right hand side is 2000. Therefore, you can get the A directly. So my A is 150 over 2000. That is going to be 0.075 meter per second squared. So when you consider system, you will get the A directly. Now to find the T, okay, the tension in the cable. So you can just consider either the car, okay, the car will be this, or you can consider the trailer. Alright, so it's up to you. So I will use car. So now when I refer to the car, again towards right side is positive. So I have D, I have Fc, I have T. Right? So the D will be positive, T and Fc will be negative. So it will be again using F equals to ma. So now D minus T minus Fc equals to mc times A, the mass of the car. So replace all values. The T is just remains. Then Fc already given in the previous calculation. Then the MC is 1700. Then the A already counted 0.075. Then from here, to get the T, right, since from the calculation this is minus T, so I will move the minus T to left side and move these two terms to right side. The right hand side to the left side, sorry. The minus T move to right side and then the right hand side move to the left side. Then I will be getting the T. So from here, my T is going to be 700 minus 400 minus 1700 times 0.075. Then from here, you will be getting 172.5 newtons. So this is how you get the A from the system and the T either from the car or from the trailer. Now this is a first method. If you do not prefer considering the whole system, probably you can just consider the car and trailer in the beginning. So when you consider car, it will be D minus T minus Fc equals to MCA, right? So this is F equals to MA, whereby you consider the car. Just copy this. But then now you have two unknowns. Okay, so then you will just write 700 minus T, Fc is 400, then this is 1700, then A. Let this be the first equation. Now you consider the trailer. So the trailer, you will have T positive, Ft negative, right? So I will just write T minus Ft equals to Mt times A. So T minus your Ft is basically 150. Then the mass of the trailer is 300. Then A. This will be two simultaneous equations. So you have to solve these two to get the T and A. So at last you will be getting the same answer. Okay, so I will just give you the hints up to here. Then you can just solve the simultaneous equations. So that's all for this question number 4. Okay, number 5. A straight slope of length 60 meters is inclined at an angle of 12 degrees to the horizontal. A bobsled starts at the top of the slope with a speed of 5 meters per second, and then it slides down to the slides directly down the slope. Okay, let's say for example, this is the diagram. Here is 12 degrees to the horizontal, and then the length is 60, so 60 meters. Here is 60. Let's say u is 5, so u equals to 5. And then now A is given that there is no resistance to the motion. Phi is speed when it reaches the bottom of the slope, when it reaches here. What is a V? Okay, so now from here I can just use F equals to ma. But first of all, alright, okay, that's all. So now you are not given what is the mass of the bobsled, so I can just let it be mg here. Okay, and then here I can say now, since it is going downwards, this is the A, so I have to resolve, right, the mg so that it is parallel to the A. So which means now here when you check, this is 12, which means here is 12, right? So now when you resolve vertical parallel to the plane, I would say parallel to the plane. Okay, so this mg you resolve here using the alternate angle 12 degrees. That is going to be sine. So I will get mg sine 12 degrees. That is ma. And now here I need to get my a. So my a is basically, okay, now the m will be cancelled off from both sides. So it will be g sine 12 degrees. G is replaced by 10. So 10 sine 12 degrees. I get my A as 2.079 meter per second squared. Alright. So now I need to find out the speed. So I have the A, I have U, and I have the S. This is the S. So then I can just use the formula V squared equals to U squared plus 2AS. So my final speed, which is a V squared, my u square is 5, so 5 square, my u is 5, so u square becomes 5 squared. 2, my a is found 0.7, sorry, my a is 2.079, then my s is 60. Okay, then from here you will be getting 274.48, hence my v is square root of that value, and this is going to be 16.6 meter per second. So that is the A. Now B is given instead the coefficient of friction between the bobsled and the slope is 0.03. Find the time it takes to reach the bottom of the slope. Okay, so now you have friction, right? That means the plane is rough. So again, here is 12. Then this is mg. Here is 12 degrees. Now, since it is moving down, okay, this is 60 meters moving down. So now the A, you have to recalculate, right? And then we have a frictional force, coefficient of friction. That means this is rough. So since the motion is going down, that means the frictional force is going up. This is your Fr. And then the R is directly perpendicular to the plane. So which means the R you have to resolve the mg, okay, in that direction. So that means now here I will write F mu R equals, Fr equals to mu R. Your mu is given 0.03. This is 0.03. Now your R is basically balanced with mg sine or cos 12. So mg cos 12 degrees. Okay, so now again to get the time. Before I get the time, I have to find the A first. What is my new A? So my F equals to MA. So now, again, my F here, right, it is resolved parallel to the diagram, parallel to the plane. That means that is going to be mg sine 12 degrees, then minus the FR, because when you resolve, that is going downwards. So your FR is going upwards. So this is minus FR equals to MA. And now you replace the FR by this. So I will get mg sine 12 degrees minus 0.03 mg cos 12 degrees, that is MA. So from here, you need to get the A. Alright, so now the G is replaced by 10. So my A is basically 10 sine 12 degrees minus 0.03 times 10 cos 12 degrees. Therefore, you will be getting 1.7857 meter per second squared. Okay, now I need to find the time and given the S. So use the formula S equals to UT plus half AT squared. Again, S is 60. The U, initially U was 5. Okay, from the question here, 5. So which means I will write U equals to 5. So 5T plus half. Now my A is replaced by this value. So 1.7857 T squared. And now, when you simplify everything and just rearrange, I will be getting 0.89285 T squared, when half times 1.7857. Then plus 5T, the 60 move to the other side becomes minus 60 equals to 0. Now to find the T, this is a quadratic equation. So solve the quadratic equation using quadratic formula. This is a quadratic formula, but then now your X becomes T, because you are solving quadratic equation in terms of T. So now I list down the A first. My A is 0.89285. I give more decimal places for the working. B is 5. C is minus 60. So now my T is minus 5 plus minus square root of B square, which is 5 square, minus 4, 0.89285 times minus 60 over 2 times 0.89285. Then from here, you will be getting the answer of negative 11.5, or probably I show you the value inside the bracket first, inside the square root. The square root value is square root of 239.284 over 1.7857. Then from here, you will be getting two T values, negative 11.5 and 5.8626. But we know that T must be positive. Therefore, your T is going to be 5.86 seconds. That is the time taken to reach the bottom. Okay, question number 6. A particle moves in a straight line starting from a point O. The velocity of the particle at time t seconds after leaving O is v meter per second. Is given v expression where k is positive constant. Now the maximum velocity of the particle is 4.5 meter per second. So because of this maximum means that you need to find dv dt. Okay, equals to 0. Then your v equals to 4.5 meter per second. Now show that k equals to 10. So use this concept. So now means that our v is kt half minus 2t minus 8. So now differentiate the v with respect to time. So keep the k. When you differentiate, our formula is differentiate x degree n, that is nx n minus 1. Okay, so from here, you will get half t. Half minus 1 is negative half. Then minus 2t becomes minus 2. And now this can be simplified into, okay, t power negative half means I can move it down. So that means you get k over 2 square root t minus 2. That is your dv dt. And now dv dt equals to 0. Okay, then the v equals to dv dt equals to 0, and then the v equals to 4.5. So now I let this be 0 first. You should get the t value. So it means that k over 2 square root t minus 2 equals to 0. That is my dv dt. Then now to get the k, right? So from here, you need to find the k, which means now I have two variables, k and t. I need to eliminate the t. So which means k over 2 square root t equals to 2. So to eliminate the t, get the t as a subject, which means this square root 3 t, you move up, the 2 move down, which means now here I will be getting square root t equals to k over 2 times 2. That is k over 4. So my t, you just square both sides. That is k squared over 16. That is my t. Get this as first equation. The second equation is we get it from the v. Okay, that means when dv dt equals to 0, my v equals to 4.5. This 4.5 can be expressed as 9 over 2. Okay, so now I will substitute into my v expression. So my v is basically k square root t, right? K t power half minus 2t minus 8. So now my v is replaced by 9 over 2. And then at the same time, when dv dt equals to 0, my t equals to k squared over 16. So now replace. It will be k. My square root t, okay, I will just take this. Square root t is k over 4, right? So probably I do not show this. Then you can see clearly. So then I will say that my square root t is equal to k over 4. So now you replace. It will be k over 4. Then minus 2, my t is k squared over 16. Then minus 8. Then now 9 over 2 equals to, okay, so this is k squared over 4 minus k squared over 8. Then minus 8. So the minus 8 move to the left side. So 9 over 2 plus 8. Right side, when you simplify, that is going to be 1 over 8 k squared. So now from here, left hand side is basically 25 over 2. Right side remains. Then now my k squared is 25 over 2. The 8 move up, becomes times. Then you will be getting 100. So my k is plus minus square root 100. That is plus minus 10. But then when you refer back to the question, it's mentioned that the k is positive constant, right? That means your k is greater than 0. Therefore, the k equals to 10. Okay, sure. So it means that we have shown k equals to positive 10. Okay, B part 1. Verify v equals to 0 when t equals to 1 and t equals to 16. So now here, just use a formula. V equals to, okay, go back to the question. K square root t minus 2t minus 10 minus 8. So we know that the k is 10 right now. That means it becomes 10 square root t minus 2t minus 8. Now, to verify means you show by replacing the values. So now I will replace a t by 1. So when t equals to 1, my v is 10 square root 1 minus 2 times 1 minus 8. This is going to be 0. And then when t equals to 16, your v is 10 square root 16 minus 2 times 16 minus 8. This is going to be 10 times square root 16, that is 40, minus 32 minus 8. That means you get 0. So with this, I have verified the two values. Okay, now part 2, find the distance traveled by the particle in the first 16 seconds. So from here, you have to be careful. When t equals to 1, v equals to 0. When t equals to 16, v also equals to 0. But then now you look at here, v equals to 10 square root t minus 2t minus 8. When the t equals to 0, okay, your v is basically negative 8. That means your V is negative 8 at t equals to 0. Okay, so now, but then when it is 1, your V becomes 0. So which means t between 0 and 1, then the V equals to 0. Okay, after that, the t equals to 16 at V equals to, when t equals to 16, the V equals to 0, which means now here I know that when t between 1 and 16, right, it will be, now you have no idea what is the value of the V, you can just check. Let t be 2. So now my V is going to be 10 square root 2 minus 2 times 2 minus 8, which means this is 2.14. So I will say that basically from 1 to 16 seconds, right, my V is positive. Okay, so look at here. T equals to 0, V is negative. So from negative to, from 0 to 1, right? That means this is negative. So when negative, to get the distance, you have to integrate. So we know that distance S equals to integrate V dt. Okay, but then because of here negative, that means when you find the distance, you have to do separately for the integration. So what I do is here I will write S equals to distance and S equals to integrate V dt. So now my S, okay, equals to integrate the V is 10 square root t, so 10 t degree half minus 2t minus 8. Then dt, but for 0 to 1, I put a modulus because the V is negative, which means when you sketch a graph, the V against t, it will be below the x-axis. Then plus integrate from 1 to 16. Okay, because you need to find first 16 seconds. Then it will be 10t degree half minus 2t minus 8 dt. So you have to split it into two integrations, even though this is the formula. Now here, when you integrate 10t power half, that is 10t degree 3 over 2 divide by 3 over 2, that means you times 2 over 3. Okay, because our integration is integrate xn dx, then you have the plus 1 degree over the new degree. This is when without limits. So here minus 2t squared over 2, then minus 8t. Limits 0 to 1 and put a modulus. So same goes to the other one. So it will be, this is 20 over 3. Then t power 3 over 2. Then the 2 and 2, basically you can cancel off. That means you are getting t squared. So minus t squared minus 8t. This will be your integration. So now replace the values. So firstly replace the t by 1. So I'll get 20 over 3 times 1. You still get 1. Still get 20 over 3. Then minus 1 squared minus 8 times 1. Then you minus when the t equals to 0. So everything is 0. Put the modulus. And plus. So here is going to be 20 over 3. Replace the t by 16. Then minus, okay, when the t is replaced by 1. So everything, when the t with any degree, it will be 1. So okay, this is your calculation. Now for your information, the first one you will get modulus of negative 7 over 3. Then followed by 1280 over 3 minus 256 minus 128. This will be the first three values from the square bracket. And then minus, now for your information, these three values are same as the previous. That means it will be negative 7 over 3. Alright, so the first value after the modulus, it becomes positive 7 over 3. And then all the rest, when you calculate all of this, right, it will be plus 45. So at last, you are getting 142 over 3. That is the distance. Okay, let me check any, okay, meter per second. So it will be 142/3 meters. So done for this question. Now for question number 7, a particle P of mass 0.2 kilograms is projected vertically upwards from horizontal ground with speed 25 meters per second. Show that the speed of P when it reaches 20 meters above the ground is 15 meters per second. That means this is the ground. Okay, here is the particle P. This is a P. Move up. Okay, like this. This is the P. Projected upwards. So U equals to 25. So U equals to 25. This is P. 20 meters. Okay, so the speed, you want to show that the V, when here, 20 meters, the V equals to 15 meters per second. Want to show here. Okay, so what to do is, I will just refer to upwards force. So upwards consider positive. So now your V squared equals to U squared plus 2AS. So I want to show this, okay, show. So that means your U squared is 25 squared plus 2. The A is negative 10 because the A is supposed to be going down. Alright, so S is 20. So with this, you are getting 225. Therefore, your V is square root of 225. That is going to be 15 meters per second. So we have shown this. Now, when P reaches 20 meters above the ground, okay, that means it's here already. It collides with a second particle Q of mass 0.1 kilogram, which is moving downwards at 20 meters per second. P is brought to instantaneous rest in the collision. Now B, find the velocity of Q immediately after the collision. That means now here, when it reaches 20 meters, here is 20 meters. Okay, your P is over here. It collides with the Q. Here is the Q. This is Q. Okay, here is the P. So basically the Q over here, this is the initial position of the Q. So now, initial position, this is a Q. So the Q actually moving downwards at 20 meters per second. That means the UQ is 20 meters per second. Right? And then now from here, right after collision, the P will be rest. That means, right? So for this case, I want to find out the velocity of Q immediately after the collision. So for information, previous question we have proven that when it reaches 20 meters per second, 20 meters, the velocity for the P is 15 meters per second. That means at this moment, right, my UP is 15 meters per second. Alright, so I have to refer to the conservation of linear momentum to solve this question. Because collision involved. Okay. Now, for this, I will just write before the collision, right? Or, yeah, before the collision, MP UP plus MQ UQ equals to MP VP plus MQ VQ. Okay, so the MP, now go back to the previous part. MP is 0.2 kilograms. So now here, MP is 0.2 kilograms. MQ is 0.1 kilogram. So now just replace. I'll get 0.2. Now here you have to be careful. The Q moving down, the P is actually moving up, right? So it means that now I will treat the moving up as positive. So here is going to be 15 for the UP, and the MQ is 0.1. Since the MQ is moving down, that means it will be negative. And now MP is 0.2. VP will be 0 because right after the collision is rest. So 0 plus 0.1 VQ. So here is VQ. Right? So here I will use orange color. Then from here, when you solve, the left hand side, first term 3, then 0.1 times minus 2 is 2, is minus 2. Then the first term will be 0 because 0.2 times 0 on the right side, first term will be 0. Then you left 0.1 VQ. So now 0.1 VQ, 3 minus 2 is basically 1. Therefore my VQ is 1 over 0.1 and I get positive. Okay, so when positive means that I treat positive upwards as positive. That means now here I will write VQ equals to 10 meter per second upwards. Okay, so you have to write down clearly whether it's downwards or upwards. So it will be upwards because I have found a positive value. And I treat I treat upwards as positive. So that's why you have to write down clearly here. Upwards as positive. Now, when P reaches the ground, okay, because we know that when it is come to rest, then it will go down. So when P reaches the ground, it rebounds back directly upwards, rebounds with half of the speed that it had immediately before hitting the ground. So C, find the height above the ground at which P and Q next collide. Okay, so now here I have to draw the diagram, which is this. Okay, this is the ground, right? This is the ground. So your P, this is 20 meters. So your P collides with the Q. Okay, Q is here. Initially, the Q is here. So now the P rests a while. After that, it goes down. Okay, so when it reaches the ground, it rebounds directly upwards, and with the half of the speed. So now here, I know that this V is, at first, it will be 0 because it come to rest. So now I need to find out what is the V1 here, V1P. Okay, this is a V1P. How much is this? So this is V1P. Because I know that V2P is going to be half of V1P. Okay, as stated here. Now, from here, what you need to do is this, because from the previous calculation, we know that right after the collision, this Q, okay, this is the initial Q. This is T equals to 0, the Q. So it goes up, alright? So when it goes up, when it reaches the highest position, let's say this is the high, I'm not sure where is the highest position, then it will go down. So when it go down, it will collide with the Q, the P here. That means probably here. Then this is the second collision. Okay, so that is the motion here. So this is the motion, this is V to P. Then I need to find out what is the height above the ground at the second collision. Okay, so now what to do is I need to find out what is my V1 first, V1P. So since V1P, it goes down, okay, so for the first part, V1P squared equals to UP squared plus 2AS. Okay, now if my UP, it will be 0. because it stops a while first. Then plus 2a, a will be 10 because it is the acceleration is always pointing downwards. So it is the same direction as the v1p. Therefore 10. The s is 20 because it goes down 20 meters before it hits the ground. So 20. Then from here you will be getting 400, which means now my v1p is plus minus square root 400. That is going to be, I consider when you refer to my diagram, it is going down. So when going down is positive. So 20 meter per second. So I know that V1P is 20 meters per second. So my V2P, right? So my V2P it will be half of the previous value. So but then half of the previous value, but V2P is going up. Therefore, it's negative. Therefore, it is negative 10 meter per second. Okay, and then now I need to find out how long time it takes for the P to reach the ground. Okay, so again for the P going down, right, S equals to UT plus half AT squared, the time. So now the distance is 20, the U is 0, okay, because of the UP, the time I do not know, plus half, since the motion is going down to reach the, the P is going down to reach the ground, so the A is positive, 10, and then T squared. Then obviously from here I get 20 equals to 5T squared. Therefore, your T squared will be 4, and hence your T is 2. That means P takes 2 seconds. Okay, takes 2 seconds to reach to reach the ground. Now I need to find out, right, within that 2 seconds where is the Q. So now for the Q, okay, since it's going up, okay, at first it's going up, so the Q here was 10 just now. This one was 10, going up with 10. So this is 10 meter per second. So now here, when it reaches the highest position, it will stop a while. Okay, so when Q reaches highest position, the VQ will be 0. So now I use the V equals to U plus AT. So the VQ is 0. The U now is 10. Okay, from the previous question. So A is negative because going up is negative, right? So here negative, T is just remains as T. So now here it will be 10T equals to 10. That means T equals to 1, which means, right, that means Q takes 1 second to reach the highest position. One second to reach the highest position. This is after first collision. Right. So now, so here after the first collision. So after the first collision, it takes 1 second. Means that to reach here, just 1 second. Right? Just 1 second. Which means at the same time, to go down to the same position. So this is 10. So that means here 1 second, right? So to go down to the same position, it will be just 1 second. That means within the 2 seconds, right, when the P reaches the ground, actually the Q is going back to this position. Alright, so now when it is going back to this position, so I need to find out when the P bounce back, okay, it will collide with the Q. So which means probably my P is here. So when it bounce, probably is here. This is my P. Okay, then my Q will be at here when 2 seconds. That means when the P over here, this is your P, right? The Q is over here, right? So you consider these two. This is my Q. Then now, let's say it reaches here, the Q reaches here, then it collides. So that means I need to find out the S. This is my SQ. Okay, so this is my V. Going up, this is my V2P. And here is going to be my SP. So my SP plus SQ will be 20 meters. Alright, so now my next calculation, it will be SP. Okay, so for the SP, since it is upwards, your P is going upwards, right? So it will be using the formula of SP equals to, this is my P. This is bounce back. When P bounce back from the ground. So my SP equals to UPT plus half AT squared. Okay, so now my SP here, it will be V2P, right? Because bounce back. So here I shouldn't write UP. I should write V2P. So that is going to be 10T plus half. Because going up, I treat going up as positive. So the A is negative now. Okay, then T squared. So here you get 10T minus 5T squared. So this is my SP. I let this be first equation. Then now for my Q, okay, for my Q, because it goes down, therefore my SQ equals to UQT plus half AT squared. So now when you look at here, basically the UQ is the 10, right? Because going up with 10 at this moment over here, at this place, the UQ will be 10. But it is positive now because it's going down, right? Going down. So because going up is negative, going down is positive. So from here, I choose positive. I consider going down as positive. That's why here is 10T plus half. The A is also going down. So you will be getting 10T plus 5T squared. So this is a second equation. And we know that SP plus SQ equals to 20. Okay, the total distance here. These two plus together is 20. And now I need to find out what is my SP basically. So then before I get the SP, I need to solve the T first, which means now 10T minus 5T squared. So substitute first and second. So now here you will be getting, okay, so no need to write 1 and 2. So just write this, then plus 10T plus 5T squared equals to 20. That means now here you will get 20T equals to 20. So I know that my T is going to be 1. So which means when T equals to 1, they will collide, right? So I will write when T equals to 1, P and Q collide again. So now the height above the ground, that is going to be SP. So SP equals to, substitute into this formula, 1 minus 5 times 1 squared. That is going to be 5 meters. Okay, so done for this height above the ground for the second collision. Okay, so I have completed this paper. Thanks for watching. And this is already come to the end of the videos. Thanks for watching. Please subscribe to the channel if you enjoy watching my videos, and stay tuned for more upcoming videos. Thank you everyone. Bye.